Good morning, everyone. My name is Zafar Mohammed Gauss, and welcome to this session around the climate change from a global perspective using space and spatial. First, I'd like to acknowledge that I'm speaking from Orangery land and pay my respect to elders in the past, present, and emerging. This is an Australian acknowledgement to our respected elders. So today we have a panel, a mix of academia, research, industry, and professional body, and we are quite lucky to get the diverse thoughts around how space and spatial will play an important role in climate change. And it is call for action. And spatial plays an important and vital role in managing and communicating the impacts of climate change. And I'd like to thank my colleagues who have taken their time to join us in this live session, and also like to thank KTN for providing this opportunity for us. This session is hosted by Surveying and Spatial Sciences Institute, Australia's peak professional body who bring surveying and spatial professionals together. So I'd like to invite you to participate by sending your questions in the interface from any speaker, and those questions will be broadcast to myself as the panel chair, and we'll put these questions to the panelists respectively. It's a 90-minute session. I'm sure this will be an engaging session, and everyone will get a message and opportunity after hearing this discussion to create a positive and enduring impact. With not further ado, I would like to first introduce our first panelist, Professor Alison Keeley from RMIT University. Professor Alison Keeley is also the chair, is a co-chair with the International Society on Positioning GNSS, but also plays a vital role as an industry and academic leader in Australia and overseas on taking space application, positioning, and provides guidance to the researchers and next generation workforce. Professor Alison Keeley, floor is yours.
Thanks, Zafar. Can you see my slides okay?
Yes, very clear.
Okay, thanks. I'm very glad to be here. This is a great opportunity to talk about how space and some of the activities that are going on in Australia in the space ecosystem can be related to emissions reductions globally. So I think I want to start off in some ways with the end of my talk. Space has always been an inspiration. Ever since the Apollo missions started taking photos of the Earth from a distance, we were able to get a very unique perspective on what our Earth and our planet looked like. And this unique perspective started to give us access to science, or ways of thinking about science, about the planet itself. Now, there's always been this intimate relationship between space and spatial. There's always been a connection in the way these two domains interacted and fed information into the kinds of models that helped us to understand the kinds of physical and environmental phenomena that were affecting the planet as we know it. So it's no surprising that the concept of Space 2.0, which is really the commercialization and the democratization of space, is doing something really exciting right now. It's putting space and spatial in the hands of the broader community. The information that is being collected by these really sophisticated yet consumer-grade type space systems are really supporting our ability to involve the general public in being able to contribute to the intentions of climate change modeling and making decisions, at the same time as providing data sets that allow decision makers to make really important decisions about our future. One of the biggest changes we're seeing that is really impacting on this area is the concept of space now being small, smart, and many. We're moving around away from the idea of exquisite and expensive satellite technology and sensors to wanting to deploy large numbers of small satellites in orbits that allow us to really quickly cover the spectrum of data sets that we require. And we're seeing companies like OneWeb and Starlink doing this in large numbers in a way that if we think about the diversity and the quantity of information that is now available to us and what we can do with that information, not just in the context of Earth observation and sensing data, but also in terms of the way we're distributing communications and the way we're distributing all of this information across the surface of the Earth, as well as further upwards into space to support even more in-depth space exploration as well. So this is one of the really big changes that we're seeing, and we're expecting through to 2030 to see a complete explosion in the tens of thousands of satellites being put up there. The question is, are we well placed? Are we well placed to coordinate all of the activities that are required for us to take advantage of all these developments? Space is also now, as many of the other speakers on this panel will talk about, is we've been using space in a spatial domain to answer many questions related to carbon emissions and how we do this. The concept of smart cities has been around for a long time. It's really how we use our technologies from space to build digital twins, models of the cities that allow us to make better decisions. It's about using satellite positioning in a way that tells us that we can use transport systems more efficiently. We can communicate using space technologies with the concept of Internet of Things, to live in a connected world that allows us to share information. Agriculture, forestry, deforestation, all of these are spatial applications that are using the new data sets, the new capabilities that are emerging. But what this is raising for us as a sector is the challenges that are involved. Do we need more data? Can we handle all the data we have now? If we get more data into the future, well, what do we do with it? How do we best take advantage of that? In terms of positioning, navigation, and timing, we've all used GPS. We all know about GNSS. And if it's one thing we know is that it has vulnerabilities. Jamming, spoofing, all of these things has created infrastructure dependencies that we now need to look at in order to secure all of this science that we're generating so that the decisions that we're making are now secure as well. The LEO satellites, the low Earth orbiting satellites, which is the thing that's driving our new space and Space 2.0 environment, is a really exciting thing. It's not going to open up comms. It's not going to open up Earth observation and sensing in really interesting ways. It also gives us new systems to think about, well, can we use this for positioning? Can we use all those satellites that are going to be in space, 10, 50,000 and more? How do we use them more efficiently? How do we task them to answer the questions that we really want to answer? And space is an ecosystem then. It is not about satellites. It's not about sensors. It's not about data. It is an ecosystem, and we need to build that ecosystem in order to really fully take advantage of what's happening in the space sector and use it to our advantage for societal benefits, and in particular, things like climate change and net zero. So in Australia, we have something called the SmartSat Cooperative Research Centre, which is a research environment that's been created to do several things. It has been designed to foster an integration of industry, academia, and government into one environment where we leverage all the powerful innovation in the R&D and make that available to the commercial world, make that available to the public good, make that available to citizens so that we all have access to that powerful research and innovation capability, so we can start taking advantage of how that can really help society. And we're doing that by looking at a set of demonstrator projects. We're looking at water quality. We're looking at emergency management. We're looking at defense and national security. All of these integrated with common spatial problems and spatial missions. All of this designed to tease out activities and opportunities in which, if we're able to model, if we're able to measure, if we're able to predict, then what we can do is we can minimize impact and improve the resilience of society in all of these domains. So to kind of wrap this up, I think space is about big opportunities and grand challenges. And what are these big opportunities and grand challenges? Well, in Australia, we have a unique opportunity to play a role in intelligence, leveraging our expertise in AI and data analytics to deliver onboard distributed computing systems, to really say, it's not about the data that we're generating and more data. It's about being able to generate products and knowledge out of that data and to very quickly get those in the hands of the decision makers. It's about resilience, not just in terms of the information and the data and the systems, but resilience in terms of the human and personnel resources available to support space 2.0, 3.0, and 4.0. So resilience in terms of skills capability, diversity, and inclusivity. And then there's sustainability, not just sustainability in terms of being able to build better models and monitor and measure our ability to contribute to climate change, but sustainability in the things that we're putting into space, sustainability in the products and services that we're developing so that we don't have to reinvent them as new technologies and new sensors emerge. And then coordination. How do we make all of this stuff available to the people who need to access it? How do we secure it and make it a trusted resource and national asset? So my challenge for us as a space and spatial community is that accelerated activity that really creates impact for climate change and net zero means that we have to address all of these issues in parallel. And that, for me, is the biggest challenge facing the space and spatial industries today. Thank you very much.
Thanks, Alison, for the insights, because usually space is all about sending astronauts and Mars studies. And I think you brought down the reality of how this could be very impactful, but also highlighting the challenges there. I now like to welcome Nathan Eaton, my good friend, and also the executive director of NGIS, a company in Australia that has been making some significant impacts on climate change and working on Earth observations. Nathan, floor is yours.
Thanks, Zafar. And wonderful presentation, Alison. That was great. And thanks for SSSI for the opportunity to be speaking as part of the team. So my name is Nathan. I work for an industry organisation called NGIS. And today I just wanted to go through some of our thoughts and experience with how we're applying geospatial capability to address climate change across a number of different areas. And so it is wonderful to be speaking to everyone as part of the initiatives at COP26. So there's been some fantastic press and releases already, and really looking forward to more significant releases to come over the next week or so as COP26 progresses. What we're seeing is in industry a lot of really significant high-level commitments to sustainability as part of climate change and climate action. So we're seeing large corporates have climate change and sustainability as really one of their key pillars for their strategies moving forward. And this is across a range of industries. And what we're also seeing is many of these organizations have very significant global supply chains. So we're seeing this convergence of all of these high-level commitments from corporates, but then also the transition from public sector into actually having these commitments to become legally binding. An example being the European climate law, where they're actually writing in the goals as part of the European Green Deal for climate neutral Europe by 2050. So actually setting legally binding targets of net zero greenhouse gas emissions by 2050. So we have this great combination of corporate commitment. We now have transition into legally binding commitments. And then we're also seeing a lot of very specific sustainability commitments. So starting from very broad, high-level corporate pillars around sustainability, but then actually going into very specific action plans around what actually will be taking place around these sustainability commitments. An example is in the palm oil industry, where more than half of the companies exposed to forest risk currently have all made a public commitment to address deforestation, and they've all made very specific commitments that are both tangible and require data and monitoring to address both current state and the transition to future state. And there's a number of these examples globally across many different industries. There's a fantastic initiative down in our area in Australia and New Zealand called the Hewaka Ekanoa Initiative, which is a farm-level greenhouse gas emission reporting initiative, a public-private collaboration, where 100% of all New Zealand farms will need to actually know their total net farm greenhouse gas emissions by the end of 2022. So this isn't a 2050 timescale, this is very near term. So an understanding of greenhouse gas by 2022 at a farm level, and then full systems for doing farm level accounting and reporting of all agricultural emissions at farm level by January 1st, 2025. So this is where we're seeing those high level commitments turn into these really specific action plans around addressing climate change. More broadly in Ireland, we have the Kerry Group, and the dairy sector accounts for around 3% of annual global emissions, which is a similar proportion to aviation. And you can see some of the very specific commitments from the Kerry Group around moving to 100% renewable electricity within 12 months. And by 2030, reducing all of their emission intensity by 30% across their entire global supply chain. And then 100% of all raw materials being used will be responsibly sourced by 2030. So we're having this fantastic combination of high-level commitments coming into very specific action plans. I think where I'm going to head to is the need for geospatial capability and data to really understand how those action plans are being addressed. And without this geospatial capability and data for these global supply chains, very difficult to understand their actual footprint. And some of you may have seen as well is the commitment around methane gas emissions. So in the United States, methane accounts for around 10% of all human-caused greenhouse gas emissions. But methane, even though it's a small percentage, is actually a short-lived climate forcer, which makes it particularly destructive greenhouse gas. And so to give you an idea, 1 tonne of methane in the atmosphere has about 80 times the warming impact of 1 tonne of CO2, so 80 times. And science has suggested that over the next 10 to 20 years, the global temperature response from methane emissions is at least as large as the actual emissions due to CO2. And if you go through, this is available online, the US Methane Emission Reduction Action Plan. There are many, many really specific activities that are actually using data and geospatial capability to address methane gas emissions. And so this is part of a global pledge for a number of governments to address methane emissions in particular. So I think around 90 governments have committed to backing this pledge. Unfortunately, that not including Australia at the moment. And as part of COP 26, you can see a lot of the principal partners supporting the initiative. One in particular is Unilever. They've got some great presentations coming up. And so my company, we've had the privilege to work with Unilever on their sustainability agenda over the last couple of years. particularly around deforestation and their supply chain and their commitment to 100% deforestation-free sourcing of palm oil. And you can see some of the commitments from a Unilever, a large manufacturing organisation, that have actually set out targets for zero emissions from their operations by 2030 and zero emissions from their products by 2039. And they actually put together their climate transition action plan and made that available for voting by their shareholders. And of those shareholders that voted, 99% were in favour of the actual action plan, which gives you an idea of the sentiment and will towards actually addressing climate change. And so what are we then seeing from Geo? What's our role as a geospatial community? And I think Alison highlighted on some of the advances in satellite technology and observations, which is absolutely a key part. And then for us, also, as Alison was mentioning, it's about data for decisions, which also includes how you actually put those decisions in the hands of the people that need it, which comes into communicating the science effectively. And climate change is very much a global challenge, as we're seeing, but I think one of the key opportunities for Geo is to identify what those local impacts are, to actually really personalise what climate change means to communities so that adaptation can take place and mitigation can be encouraged by further understanding what those impacts will really be. And really, in the area that we work, we're seeing that the opportunity is around taking all of this data that Alison was talking about, so the tens of thousands of satellites producing more and more observations. But we have this great opportunity where cloud technology is getting to the stage with geospatial capability that we can use this data effectively. We can actually process the petabytes and petabytes of data at scale to actually distill down to the insights that are going to help us provide the information that will help shift the needle in terms of addressing climate change. So it's that combination of the proliferation of data and the availability of data, but the core component for us is cloud technology to be able to use that data effectively. And then we have this combination of what we're trying to do with Geo is to observe our planet using all of these satellites and other sensors, IoT, which then presents not just the opportunity to distill that information down into actionable metrics, but to actually accelerate science. So being able to allow scientists to have more information at their fingertips and to use cloud technology to run scenarios more effectively than they ever have before. So we're going to see this really rapid evolution of new science coming out all the time. So whether it's scientists having more information at their fingertips around rapid ice sheet melt from Greenland and the Antarctic, they'll start to have more information to be able to create more and more accurate models. And these models will be covering a number of different areas directly affecting climate change and carbon emissions. So whether we're looking at global deforestation and using satellite technology to monitor that effectively, whether we're actually looking at surface water percentage change, as you can see here, water security and water quality being a key issue in many countries and a key impact of climate change with rising temperatures. Or this example of actually detecting methane plumes as part of the action plan that was put forward by the United States government from the Carbon Mapper initiative that's attached to NASA, and how this information can be captured with satellites for understanding where methane gas is being emitted and to be able to address those in the supply chain. So a fantastic opportunity for scientists to leverage all of this information. And then the opportunity for us is to take that science and, as Alison mentioned before, put it in the hands of the people that need to use it. But really what we're excited about is the opportunity to localise that communication. And we think that's going to lead to significant impact. An example being the recent release this year of the IPCC 6 assessment report, where the case was made for a very high level scenario where sea level rise could be up to 2 metres by 2100 and 2150 by a 5 metre increase, which is the first time that significant increase has been captured as part of the IPCC reports. And so those global projections, we've then been working with our partners at FrontierSI and Graham Koenig, who'll be presenting next, around how we take that science. We use then cloud technology to distill that down into communicating that effectively. So actually taking those numbers, if you like, but then actually using geospatial capability to show exactly what that looks like for communities. And down in the Oceania region in particular, obviously we've got effects for Australia with the large coastline, but then we also have effects for our neighbours in the Pacific that are very much on the front line with climate change. Very low-lying areas in the Pacific Island countries, where having this information available and the ability to use geospatial capability to not just create the models, but to then communicate those, such as this island in the Vanuatu group of Malakula, where we can actually use that information to communicate and display what that looks like in terms of future inundation to this particular community, and then use geospatial capability to actually identify the metrics. So this is the full end-to-end delivery, if you like, of climate science into the hands of the people that really need to use it and to create the awareness that will lead to adaptation. And I'll just finish off with an industry component looping back to Unilever. And from an Asia-Pacific perspective, you have global supply chains with significant sourcing patterns from the Asia-Pacific region. A specific example we've got here is the work that we're doing with Unilever around addressing their global deforestation, where around 90% of all palm oil is coming from Indonesia and Malaysia. So within our backyard, within our Asia-Pacific region, we have a large amount of area to cover and monitor in terms of sustainability and in terms of addressing these very specific action plans that organisations and governments are actually making towards commitments for climate change in the future. So that's where we're seeing the progress towards the use of geospatial technology and the opportunity to leverage all of the data and the sensors, and then to use high-end new geospatial capability to put that in the hands of the people that need it. So yeah, thanks so far.
Thanks, Nathan. Really mind-blowing examples and a global perspective from a geospatial, and you very well articulated, how the geospatial capability as an input to the global supply chain is very important, and some very good industry examples and actions and targets shared. I'm sure our viewers will be having a lot of questions. I would encourage the delegates who are in the session to use the Q&A box, please, to put your questions through so we can ask the panelists specific questions, but also please use the functionality and the platform to network with each other using the chat box after this event. With now industry insights, especially from a global perspective and showing some actions on climate change, it's my privilege to welcome Dr. Graham Gurnage, CEO of FrontierSI, which is one of the peak research bodies in Australia who brings along government, industry, and academia from a research perspective. It's also good to note that FrontierSI and Nathan Eaton's company, NGIS, were formally recognized at the Paris event for their work on climate change using geospatial. Graham, your slides, can you put it in the presentation mode? Is it in a presentation mode?
Try that. Can you hear me so far?
Yes. The floor is yours, Graham. Welcome.
Thank you, Safar, and thank you for the time today and the opportunity to present to you. Friends, we're custodians of this planet for future generations, and nothing is more important than monitoring the health of the planet as the effects of climate change materialise in different ways. We've come a long way since COP21 in terms of technology and our abilities to monitor the planet, and that technology ramp is going to continue. So today, I really wanted to speak to you about the nexus of space and spatial and how we can take the changing technologies that are before us with their vast potential to really monitor the Earth at a higher resolution, in more temporal frequency, and to provide that information into models that allow us to really hold nations to account to their commitments that have been made over the last week, and really understand where people are performing and where they're not, because that climate change, as we know, is real. Just to talk a little bit about us, FrontierSI is a not-for-profit research organisation that works right across Australia, New Zealand, in the Pacific and globally. We have a really strong set of spatial key disciplines, and we apply them right across a variety of sectors. Increasingly, we're spending more time working with space data and looking at the way you can fuse different data sets and bring all of the sense data together to provide workflow solutions. I don't need to talk about the impact of climate change too much, but when we talk, I just wanted to talk a little bit about the region in which I live. The Pacific is a very vulnerable area. Sea level rise, Nathan talked a little bit about that. Increased risk of disaster events. For Australia, we have a population that sits along the coastline. We're a very urbanised country. 90% of our people are along the coast. Most of our assets are along the coast. We're very exposed to bushfires and sea level rise in particular, and flooding. And the heat effects will impact our major industries, crop production, all of our infrastructure. So it's a very real problem in Australia as much as it is around the world. Alison talked a lot about that space and spatial intersection, and the way we think about space and spatial is really that the spatial industry provides the vast amount of data infrastructure, that content, that analytics piece, and really that last yard delivery of information to customers and end users for most of the for most industries and workflows. Space is a channel for that data to be collected and then delivered. It's really a case of that the spatial applications demonstrate the value of the space capabilities. And that nexus is, for us, as Alison mentioned, digital twins, how you bring different data sets together, how you fuse spatial data sets, and by that we mean any data that has a 3D point. How you bring all that together is really the nexus for space and spatial. Alison eloquently talked about the increase in infrastructure in space. We're going to see a lot more data coming out of space. We're going to see higher resolution data. We're going to see a lot more detection of different gases through the atmosphere at higher resolution, which allows us to do a lot more with models. We're actually using space a lot more to address the essential climate variables that are being used to monitor and model climate change than ever before. This trend of availability of sensors is going to increase, and that means we've got a lot more data available to us, and understanding how we take that data and bring it into, I'll say, a usable format is really critical. Data trust is a big issue. Understanding the resolution of the data, the currency of the data, the accuracy of the data, the provenance of the data, and building trust in that data so that the models become more trusted and the outputs of those models are more trusted is really critical. Space is playing an invaluable role in that, and understanding how the spatial aspect of that, and that's a lot around ground-based sensors, ground-based validation and of all that data is really important. And so there's a piece here around that is really about understanding that the data is trusted for the user, and that we can communicate that really into the different I guess leaders, so that they understand that the work that's coming through those models is accurate and trustworthy. Sitting right next to all of that data is the ability to bring it together, integrate it, build it into workflows, and use it properly. That's incumbent upon us to look at how we use that data, think about how it reports, and Nathan gave a very strong presentation on how that data is being used by businesses, by nations, to report on environmental, social governance. How we turn all that information into decisions, and how we actually make the right decisions now and into the future. Is really about that analytics. And now we have before us the ability to do that, as has been discussed earlier, through the different technology leaps that have been made in the last 10 or 15 years. Nathan showed a slide from the tool we've worked on together. This is something we're very proud of, not because it's a great set of technology and the data is very accurate and the tools are very simple, but because this is a platform that reaches a lot of people, and communication of that to the public is super important. The value in this tool is its ability to be used easily by anybody, and it's in the hands of people through the internet. It's very light to use, it's very simple to use, and it gets used for a variety of purposes that we never envisaged. So you can very simply communicate to people, to the public, the effects of climate change, and at a higher enough resolution that they can see what's going to happen to their area, where they live, where they work, in a very simple way over time. And this tool is, as a result of that, been picked up to levels way beyond what we expected across Australia. So I think when you think about communication of the I guess the outputs of the models, and that's very much what you're seeing here, you've got to understand that people need to see it in a very simple way, and it's incumbent upon the last mile, that spatial industry, to think very carefully about how they message the results. We've done a little bit of work in agriculture, and the point of showing these slides is that when you think about who is going to read that information or use that information, you have to really think through the user profiles, what they're looking for, how they're going to take that information and incorporate it within their business or within their life. And so I think that's also a big piece of this, is that we started with the space sensors, we get down to the person and their needs, and the important part of our communication is really understanding who we talk to. So whether that be, as in this example, the agriculture sector or the mining sector, understanding how they can use that information well to improve their business is incumbent upon us. So thank you. I'd just like to wrap by saying that the information we have is in our hands. The data sources are there. That data is going to be more available than ever. And the way we take it, make decisions around it, and then communicate that is really, really important. And spatial has a very big role to play in that. So thank you, Zafar. Back to you.
Thanks, Graham. I think it's very important that, the models, the data, and the trust in data, especially on internet and open data, and the provenance is a very vital part for decision making, because Nathan spoke about how geospatial data for decision making is important, but the trust in data is also equally important with so much data available. And I think Graham nicely touched on those points around the provenance. And I'm sure you will have some more questions, and we'll be able to come back to Graham after the presentation. It's also my privilege to welcome Graham Martin, who's the General Manager of Spatial Vision. And Graham works with a lot of local councils in Australia, but also we bring his perspective from global to local. Graham, floor is yours.
Thanks very much, Zafar, and thank you very much to SSSI for the opportunity to speak today at such an important event at this moment in time. I'm going to give you a personal perspective and then of a commercial business in Australia where we see climate change as an opportunity to assist our clients. "40 years ago, in my final year of university, I was assigned an essay topic, present a positive case for nuclear energy. Now, I would have liked to have argued the alternative. However, I went to the library, as we did then, and found out about the greenhouse effect and a new technology, heat pumps. Heat pumps would enable the electrification of the residential heating in North America. So zero carbon nuclear power could significantly replace the burning of carbon heavy fuel oil and address global warming." Now that was my essay, and that sparked my pursuit of the science of global warming and a commitment to act on it ever since. Now back then, information seemed to have more impact. However, at that time, climate knowledge was not widespread or generally understood. 40 years later, heat pumps are a ubiquitous technology for heating and cooling systems. You've got an aircon system, it'll be a heat pump. However, the debate about climate change, as we now call it, continues despite the accumulation of troves of scientific data. Data on weather extremes, unprecedented events, changing seasons, also data from forecasting models, some that have already played out and forecast to come for different carbon scenarios. Many people are overwhelmed by this array of information served up by the media and other parties. It remains a battle to convince many people of the scale of the crisis we face, despite all this information being available. So, as data-focused professionals, how do we cut through the noise? Well, it's about embedding the assets, people, biodiversity, livelihoods, and built infrastructure, the things we care about, into the picture to demonstrate the local impact and ultimately make data relevant. Let me explain. Last year, I was privileged to be trained as a climate reality leader by former Vice President Al Gore. The training highlighted extreme climatic events over the past 10 years and the people and environments impacted, as well as the opportunities for dealing with the crisis. As a geospatial engineer, I see that my role and that of the industry is to use our skills to transform the troves of available data to derive meaningful information to generate insight to people across many sectors. As geospatial professionals, our special power, if you like, is to put local context into global data. Turning data into relevant insight is our superpower. Here's how we do it at Spatial Vision. Our company comprises geospatial and IT engineers, perhaps like many here today. We are committed to enabling governments, business and NGOs with the tools, technology and expertise needed to address economic, social and environmental challenges, many of which today are climate related. Over the past 10 years, our company has been increasingly engaged by clients to help them to comprehend the dimensions of climate impact on their assets, communities and industries, and to understand the scale of adaptation or mitigation planning necessary to address that. In these projects, we utilise the latest IPC climate projection data as well as weather observations from the Australian Bureau of Meteorology to generate visual representations of the changes to our climate over the past 50 years and then the next 50 years forward. Let's look at a few examples. First of all, as you can imagine, heat waves are a major concern in Australia. A heat wave is defined as more than 3 days over 35 degrees Celsius. Local government has a duty of care towards its citizens and resources to support them. The 9 South East Councils of Melbourne making up SECA, the South East Councils Climate Change Alliance, wanted guidance on heat waves on their region and their vulnerable communities. Now, as you can imagine, there's a lot of information to draw from, but our approach to these types of projects is to firstly source authoritative data to determine the climate baseline and the relevant projections for climate and events such as heat waves. Then in this case, we worked with representative council service areas to decide the criteria for assessing the most vulnerable communities, infrastructure and assets to create a heatwave vulnerability profile. Now, as you can see, for this particular region of Melbourne and Southeast Victoria in Australia, weather observation data already shows that the frequency of heat waves over the past 40 years has doubled. And they're very likely to triple again over the next 10 years, and then, depending on the carbon emission trajectory, continue to increase. So the question becomes, who will be most impacted? In all local government areas, there are vulnerable communities. In this project, we created a heatwave vulnerability profile for each local government based on projected demographics for young children and the senior population. This map represents vulnerable communities in 2021. The information here is used by Council to focus their services to pre-equip and support these communities during heat waves. It also helped them to plan utilisation of cooling places such as public libraries and community centres. We can then see the projected frequency of heat waves for the local geography of each council. You can see in these two images here, 2030 and 2050, that the coastal sea breeze influence means that the areas away from the coast are more impacted, especially by 2050. These forecasts are used to guide future investment in open space, infrastructure and service provision. Green open space can bring down local temperatures. Libraries and community centres can operate as cooling centres. Public transport needs to be designed to cater for heat, as they're often used by the elderly, and assets should be designed for heat tolerance. This is how this information is used. So let's look at another example, this time for a catchment management authority that wanted to increase the capacity of landholders, community and local government to adapt to changes in regional climatic conditions. The authority was looking for a way to engage these groups in informed discussions. So Spatial Vision was contracted and collaboratively designed and provisioned a public spatial tool to help guide discussions about climate adaptation pathways. Again, we sourced authoritative weather observations for the region to understand the level of existing changes and to establish a baseline, then the most recent IPC projections adapted for the region. Importantly, we worked with representatives of different agricultural production types, local government and communities, to define the parameters most relevant to each focus area so that we could design tools specific to each. As we can see on screen here, the various Explorer tools enabled users to select a range of climate variables to visualise location history and projections relevant in their context. So as a result of this project, more than 2,000 land managers have been subsequently been engaged to examine how they can adapt their businesses to counter the impacts of climate change with Spatial Vision, its work providing the foundation. Our client says without it, the conversation would have sunk. But as a result of the tool, some farmers will not only avoid bankruptcy, but will survive for generations to come. This is the kind of impact that meaningful, relevant data has on communities and can truly make a difference. I'm very fortunate to be working for a company that values making a difference, with other colleagues who are truly committed to taking positive action on the climate crisis and empowering clients and communities to address their climate change challenges. So as geospatial professionals, we're uniquely placed to bring together various data and place it into a local context to inform people's understanding and plan to address our changing climate and the impact on people, livelihoods, biodiversity, physical assets and infrastructure. So let's use our superpower to make climate data meaningful and relevant. Thank you.
Thanks, Graham. I think it's quite good from Graham's talk that we saw the maps, but also the temporal aspects, 50 years past projections, 50 years past data and 50 years future data to help do that projection scenarios, but also small companies can make big impacts. Corporates are taking that action. And I think we'll have some questions from Graham's presentation from the audience shortly. Thanks, Graham. I now like to welcome Dr. Leslie Arnold, who is the President-elect for Surveying and Spatial Sciences, but also is the director of a company based in Perth called Geospatial Framework. Leslie is also a great contributor to global initiatives, especially a contribution to the UNGGIM and other initiatives that she volunteers, has been creating a great impact. Leslie will speak about the future, and welcome, Leslie, and floor is yours.
Thank you, Safar. And you can hear me?
Yes, Leslie.
Thank you. Thank you. So yes, I am excited to talk about this. Thank you so much for the opportunity. And I'm going to talk about a topic that everyone has mentioned, and it's about putting knowledge in the hands of people so we can make decisions as we move towards net zero emissions by 2050. Now, there are a lot of questions we ask, and we've been given some great examples of how we as professionals can use this data. And we can look at, we've got questions we can answer about the impact. What are the social costs of deforestation? Nathan mentioned that. What will happen to the emissions if buildings in an area I start to use more green energy? These are the questions that politicians want to know. We're going to gradually move to more monitoring applications, and we've seen some fantastic dashboards with COVID-19, how we can measure and monitor change over time. We're going to get now to the localizer, and I'm going to touch on this last question. What are the emissions associated with my property? And again, Nathan brought that up. These questions are going to be the ones that people are asking. However, when you tell someone that you are using a GIS to answer some of these complex questions, they say, wow, but where can I buy one? And which GIS is the best? Well, of course, as professionals, we know that's not so simple as that. We have to find the data. We've got to then download it. We process the information. We find that we need to fix up some errors. We need to overlay that data with some other data, which we've also got to find before we can analyze it, transform it, curate it, and then display it in a trustworthy way to actually get an answer from that information. Okay, so by the time you've drawn breath, you've already lost the people you're talking to. Count me out. There must be a simpler way of going about getting this information that I need. And why not? If I'm talking to the young today, they just say, why can't I ask Siri? And why can't I ask Google? And why not? When you think we are in this on-demand revolution, we got consumers now experience information in seconds, where we have a digital mesh of applications across the world that are just sort of layered on top of our digital infrastructure networks, including our spatial data infrastructure networks. But of course, these are fixed applications, and they are designed to answer questions that are predefined. And of course, some of our questions are not predefined. They're ad hoc. And when you think so Siri is one of the methods that we can use to ask ad hoc questions. But of course, ad hoc questions, in particular, complex location-based questions, are not yet possible. Siri's not quite up to the mark. And if we also think about just simply running a script on the web, I'm a researcher and I'm running a script and I'm looking at some correlations between a couple of data sets, you know, it can actually take me a lot of time to search that information on the web, compare, log the information, when really all I want to do is run an algorithm that will find that information for me while I go and get my cup of tea. So, so this is a new opportunity, what we can do with our data. But of course, as an industry, we don't have machine actionable data. So if Siri can't find the data, in fact, we have search engines that can't find the data. If I run a simple Google search, the search engine for a map, I will quite often hit the URL of one of our SDI portals, but I can't actually get to the data. This is the machine. The machine can't get to the data. What happens is then the person has to take over, because our catalogs are designed to be human readable and not computer readable. So Siri can't get to that information. So what we need to do is try and open up the back of our cupboards. We've created these wonderful cupboards of data, and we're putting more and more intelligent data into those cupboards, digital twins, IoT sensors, and so forth. But essentially, that information, although it's organized, is not accessible to machines. So FrontierSI, formerly the Cooperative Research Centre for Spatial Information, we entered into a research program that looked beyond our current capabilities for our spatial data infrastructures. And we moved to looking at the semantic web technologies and about integrating the data on the web, on the fly, to answer some of these questions. It was quite a large research program with 10 PhDs, postdocs, and 15 industry partners just for this particular thing. Now, if I zoom in on that diagram there, you can see we were looking at addressing the gaps in capability along the whole supply chain and working towards this simplified supply chain where the information is able to be integrated. Now, we came up with a vision for what this might look like, and we used the term spatial knowledge infrastructure to differentiate a paradigm shift. Now, I'll just draw out some keywords here. We're talking about a network of data analytics. We're talking about integrating data in real time, and we're talking about everyday decision making. So that's putting information in the hands of people. Now, to do this, I mentioned the paradigm shift. We're moving from Web 2.0 to Web 3.0. Now, this is a fundamental change in how we actually manage our data and the underlying assumptions of how we share that information and how we use geospatial information. Now, I need to mention the semantic web. It's a vision of the web of data where everything, all the data is connected. And it's about linked data, which is the format of the data. It's a different format, which is the means that to achieve this vision of the semantic web. So the semantic web is the what, and the linked data is the how. Now, our data just needs to be converted into a machine readable format, and that is the linked data format, which is the resource description framework. Linked data can be found on the web. It needs a unique resource identifier. Now, we have governments around the world now who are creating linked data, and this is really, really exciting. And to organize that data, because of course we're going to put it out there on the web, and it's this global resource, but we still need to manage it in some way. And governments are now creating these linked data registries, and Australia is one of them that's done some development and piloting the location index. And this makes it easier for the machines to locate the data, but also defining these link sets to make it easier for machines to actually join the dots between one data set and another. So the semantic web is about, it's not about getting people to think like computers, but it's actually that we are describing the world in terms that a computer can understand. And to do that, we need to develop ontologies. Now, ontologies are being developed in a number of different disciplines, particularly in the libraries area. And there's an example here. It's about the connection from one feature to another feature in the data set. And it's about that relationship, capturing that late relationship, because we're looking for meaning and we're trying to capture meaning in the real world. So a bridge goes over a road and an underpass goes under a road. They're the sorts of concepts we're trying to pick up. Now, can we transform our spatial data infrastructure so we can connect the dots? And the answer is yes, we can. And the research looked at this as well. So on the right here, you can see a current spatial data infrastructure, data in silos, but it's shared via service net to a number of other users. This is our traditional method. Now, with the SKI, we're simply trying to open up that back cupboard, the back door. We're not changing SDIs, we're building on top so that data is now accessible via this web of data or this global data resource. And then, of course, we've got our applications are still trying to access that data, but this time they can read it through the web of data. And but we do actually need something a bit clever, and we do need to establish a broker between those applications and the information on the web and how it is used. So what this research did was design an architecture that will help us enhance our SDI so we can move to this knowledge on demand. I'm sorry, my slides keep moving. So we had to develop this architecture. It's about having an interface between the user applications to our SDI data resources, and it's via a broker. And the broker is that mediator that talks to those data resources. They're essentially in our SDI, but we call them SKI resources because we're talking about linked data on ontologies, which are a bit different to our usual resources. And there's more information there on the screen in red if you want to know more about the architecture. A key thing here is that the metadata catalog is machine readable, and that's going to be an important element. Okay, so our ultimate aim here is to have knowledge on demand. And at the moment, there is way too much data out there for a human to comprehend. So being able to analyze data, the computer analyze and answer our questions is certainly a way to move forward. And I think it's a way to move forward with achieving net zero emissions by 2050. And of course, there's going to be so many new laws and policies and standards come into play that it's going to be really confusing for people. And yet, we actually want collective action. So we need to make sure that knowledge is in the hands of the people who need to make those decisions or abide by those laws, policies, and standards. So putting it into the hands of the users. Okay, so a citizen might want to know what can be done on their land in this new future, what cannot be done, and what they have to do. What is their responsibilities? And it might be around the number of cattle that they're allowed on land. Okay, we're going to take an example, very high level, using, can I use this land for a market garden? So you're out, you come across a for sale sign, you're on the ground, you really want to find out if this is the land for you. Again, new society, knowledge on demand. I'm just going to ask Siri. So now we have natural language processing that can actually understand our human language and can decompose that question into a form that the computer can understand. Now, this is really important because the next step in the process is to get the data to answer the question. So it needs to understand what subject area. That's where the term semantic search comes in. What do I need to find? What data do I need to find to enable me to answer that question? And it could be to do with the soil, or it could be to do with rights restrictions, responsibilities on land. And we also want to filter it by location. Well, the question is, can I use this land? So it's the land I'm standing on, it's my GPS location. So we need to start filtering that information in order to get a bit more precise data. All right, I mentioned ontologies. We can't just get the data. We need to actually get to understand that data and the relationships. So here's an example. We've got a person, they're at a location. That location has an address. And that location also has a land use. Now, that's one part. But of course, these models or the understanding of these rules is only one part. We also need the data. And this is how we start to build up these knowledge graphs. We can link one data set to another data set to another. And then, of course, we need to process the data. And here's an example here from one of our PhD students that asked the question about flooding. And I just want to keep with I wanted you to see what that looked like, but I will keep with the theme. So if we're looking at land, we need to gather, we're identifying the resources, we are referencing that information together. And of course, we know the GPS location, so we can identify the location within that land property, and we can do a spatial intersect. And for example, we're intersecting it through data sets such as soil salinity. If the whole property is covered in saline soils, then of course it's not suitable for a market garden. And then we need to return the results. And of course, this capability, Google does this very well. And there's multiple ways of returning a result, whether it's a text, a yes, no answer, or whether it's in map form. One thing we don't do well, and this has come up, Graham Koenig mentioned it, and it's about this trust in data. We still need to be able to trust, for people to use this knowledge, they need to be able to trust that that knowledge is correct. And so provenance data, as Zafar mentioned, is really important. We need to be able to rank, and we need to be able to rate the quality of those answers. Okay, so how close are we to this knowledge on demand? Okay, well, so far we've really only focused on technology, and you'll know from that there's more to it than this. And again, Graham Koenig touched on this when he talked about communication. So here we couldn't actually adopt the integrated geospatial information framework, which our industry has brought out, particularly through the UN, United Nations. And they're looking at the whole picture, and this hasn't been done. There's a need for global governance. We're talking about a global resource network. Standards need to be developed, particularly around ontologies. And we need to reconsider a value proposition where this information is on demand. What are the socioeconomic benefits? And the big one here is we need to be able to teach semantic web technologies to our professionals before they graduate, so they can bring these new skills that this industry sector needs into our field. And of course, there's data ethics that need to be considered too. When a human doesn't touch any part of the process, we always need to think about the ethics there. So there's some work that needs to be done there too. But it is a call to action. There are things that we can do now, and certainly looking at governments, making available data as linked open data, developing our ontologies, particularly in the research sector, vocabularies, and this linkable metadata. Thank you very much.
Thanks, Leslie. A very inspiring talk about how the open data that can be really used for meaningful decisions, and by investing, well, data infrastructure has been invested, but then how do we use this next generation knowledge infrastructure for decision makers to take advantage of the data out there with the elements of trust and ethics? And often I say this is like, water everywhere, not a drop to drink, when one of the sailors lost themselves in the ocean. And I think now with the advent of open data everywhere, but not a bite to be consumed in the workflows is the situation. And that's where these ontologies and this search engine's thought process will really help, in combination of IGIF, as you had mentioned, to bring some more confidence to the decision makers there. Thank you very much, Leslie. We have a last speaker, Mr. Tony Wheeler, who is the CEO of the Surveying and Spatial Sciences Institute, who has also been the co-organizer of this event along with me. And Tony will provide some insights from a professional body. We have heard from industry, from academia, sort of as the research sector, but what's the role of professional body? Tony will unpack that for us. Tony, floor is yours.
Thank you, Safar. Look, it's great to be here today, and we're very pleased to have been invited to participate in this event. I just want to start by stating perhaps the obvious, that geospatial technology and location data drive efficiencies across multiple sectors. When applied to reducing emissions, timely, accurate, and trusted data is the key to the solution. By measuring and monitoring what is actually happening, improvements, efficiencies, and alternatives can be applied to drive down emissions. The main sectors are probably far greater than what I've listed here, and agriculture, manufacturing, transport, government, mining, energy, environment, building and construction, and supply chain really cuts across all of those markets. As we move from data to models, interoperability between models is key to removing siloed networks and allowing free flow of data. unified information sharing. A unified approach to information sharing created by common standards will provide more insight and more solutions. Combining large flows of Earth observation data, as several of the speakers have mentioned, with in situ sensors will lead to new levels of data intelligence, and that becomes knowledge. International collaboration is, of course, absolutely fundamental in sharing knowledge to developing informed knowledge. So what's the role of the professional body in this? The industry is currently growing globally at 12.5%. In the Asia Pacific region, it's growing at about 18%. Between 2021 and 2026, a 5-year period, it's expected to double globally. So it will grow at 20% per annum globally. So the most prominent issue faced by the geospatial sector is a significant skills shortage. Within Australia, there's a lack of education and training providers to meet the needs of industry. And where there are courses on offer, there's actually a lack of sufficient places. But the other problem we face is attracting students to study those courses. Digital transformation and rapidly emerging technology is also impacting the existing workforce as some embrace it and others really struggle to adapt their role as it changes, as the rug is swept out from under them. So our role as a professional body is therefore to develop a capable and skilled workforce that drives preparedness for the rapid changes unfolding. And we'll do that by driving standards and qualifications. We'll work very closely with the academic sector to offer short courses and micro-credentialing. We'll create a range of workforce development solutions from volunteering all the way through to a series of short courses or postgraduate courses. We'll lead dialogue with industries and government to ensure that there is an environment that is attracting students with incentives to attract students to those courses where we have such a chronic shortage. And we need to attract both school leavers and people from other disciplines to move into this sector. So the 4 key functions of a professional body are advocacy. So that's influencing both industry and government policy, and ensuring that there is an environment where innovation and businesses can do well. We also run events and we have annual awards. These are very important in recognising both individual achievements and industry achievements. We drive national conversations through our commissions and through special interest groups. We offer formal and informal opportunities for networking. And we offer a means to recognise skills. So certification is fundamental, and I think it will become of increasing importance over the next decade when new skills are going to be highly desirable. So, for instance, someone who's certified to produce a digital twin would give an employer more confidence than employing someone with just a degree and a claim that they can and have produced a digital twin. So to make it happen, it's advocacy for purpose, industry and government dialogue, creating an environment for a strong sector. Industry surveys, we need to understand the skills gaps and the capability gaps. We need to produce white papers and blueprints to influence government policy, and we need to assess our progress on an ongoing basis. In terms of work readiness, as I've mentioned, industry endorsed certification and professional pathways programs, technical standards, data and models. That's very important to driving capability development and the sharing of data and models, and overall industry accreditations. We need to network for purpose. So we leverage and build environmental scans to shape the basis of industry. So if we conduct an industry survey, that forms the basis of the strategies that we roll out to strengthen the sector and the workforce. Special interest groups driving these national conversations to solve problems, develop solutions and standards. We drive innovation through those conversations and work with organisations such as FrontierSI, SmartSat, CRC, and the university researchers. And we run events, which are very important. Our local online events, our regional events, and our annual conference and national awards. So with that, I'll hand back to Safar. Thank you very much.
Thank you, Tony, and I'll request all panelists to switch on their cameras there. And Tony, if you can stop sharing, great. Folks, I know it's been a great session with so much diversity of presentations coming on board, too many things to digest. But I think when I'm seeing the questions coming from the delegates here, they're quite intertwined. Let me articulate this to the panel, and if every panelist can give a 1-minute reflection on the question there, so we should be able to get it across, and we have about 9 minutes. Okay, so there are questions across is, what can we do as an industry to influence, geospatial industry, to influence the perception of data as trusted, reliable, and worthy of use in decision making? And how do the panelists see the 3D visuals playing a role in decision making, and they are intertwined? So one is around the trust reliability. Another is making data easier for decision maker to visualization, especially 3D. So we'll go back on the same order. Professor Alison Keeley, your reflection on this question.
Look, I think for me, those two questions are in fact combined in an answer that says, I think it's a fitness for use problem. I think in both cases, whether you use 2D or 3D maps, it depends on the problem that you're trying to solve, what the users are requiring, what the level of interactivity that is required of that problem. And I think in addressing it as a what is the best solution to that meets the decision is the first way I decide on that one. In terms of trust, I think it's the same thing. I think different people often confuse trust and accuracy. And really, it's about understanding the quality of your data that engineers trust. So for me, in my domain, this is about creating traceability in the data that you're providing. So if I'm combining data sets, then I want to be able to propagate uncertainties across the data sets that I'm using. But it's also about being able to communicate uncertainty to the audience. So whilst a statistical value is useful to some audiences, visual representations of uncertainty or the variability in uncertainty across a data set and how that is represented becomes a more important way for people to trust the data. So yeah, in one line, it's a fitness for use requirement.
Thanks, Alison. I think it's communicating data quality along with those visualization makes it easier for decision makers. Nathan, your reflection working with industry, especially with corporate, how do you see this question?
Thanks, Safar. So the two questions here. So the first one around how can we influence the perception of data as trusted, reliable, and worthy? For us, it's not the perception is the issue, is how do we make data trusted, reliable, and worthy? I think what we're finding now is increasing use of data as it becomes more available, and an inherent trust in that data by parties that are using it, particularly from the public. So it's not around the perception of the quality of the data. It's the geospatial industry needs to make sure the data is quality before it gets in the hands of the decision makers. So that's our take on that one. And then the 3D maps one, for us, we're excited to see the next evolution of the digital twin to be less around ministerial presentations and looking good, and more around operational digital twins. So how do you go from all the way from UAV data capture of photo mesh and reality mesh data products, all the way through to integration with business systems and IoT, and then analytics and decisions? I think there's gaps on either side from where we currently sit in our focus in 3D that we're really excited about.
Thanks, Nathan. I think that's the way to go, to see operational spatial digital twins, making community to use it. Thanks for those insights. Graham, I'll just slightly change that question from a research perspective. Is, you could see that, dark web, false news, false information on internet around data, and your presentation highlighted on those ethics and trust. So how can research contribute to this?
Challenging questions, Afar. I think I'd say about the misinformation piece that this is about understanding how you build governments build regulations and companies take ownership for the transfer of messages. And so for me, you can build really strong, logical, data-driven arguments, but misinformation can cut right across that pretty quickly. So I don't think there's necessarily a data trust issue that can build here. It's more about the way in which we communicate and cut off some of those messages. To a certain extent, I think freedom to speak your mind and opinions need to be considered. The message in terms of climate change, I think, because there's still a level of noise around that, is that who's got a vested interest in the argument about climate change? The argument about climate change is one about the health of the planet. The vested interest in that is everybody's. So there's no one trying to. Who makes money out of that? Well, at a large level, it's very hard to put the finger on it. So I think the science can come to the fore there, and the messages around the science and the data help to offset some of the climate change skepticism and misinformation.
Thanks, Graham. Graham Martin, your reflections, especially around the visualization.
Yeah, thanks, Safar. Look, I'll go back to my theme. In some senses, I think our role is to make information accessible and understandable, and I think that's the best way to make it more transparent in terms of what it is. And I think that's the best way to address lack of trust, I guess. I'd like to emphasise Alison's point around trust and quality. I think there is a confusion between the two, and I think we need to try to spell that out to people, that there's not endless on-ground accuracy for data. It's at a certain scale, and once again, also, as Alison said, visualising that uncertainty rather than just portraying it so that people don't understand that there is a level of confidence based on its scale is something that, as an industry, I think that's our role in a way, is to communicate geospatial information and communicate it in a form that it reaches lots of people, not just our sort of informed audience. We need to reach much more broadly than that.
Well said, Graham. Leslie, how does ontology helps us in that dilemma of the trust, misinformation, and accuracy or uncertainties?
Certainly, thanks, Zafar. And it definitely does, because we can start to build rules, rules that we as humans may not follow, but rules that we know that a computer will follow, and it can be based on domains of quality, in terms of accuracy, in terms of provenance, where data has come from. Is it government? Is it crowdsourced data? And it can use that in its computation of the level of trust. But it's an interesting one, because information has to be trusted to be used, and it's got to be used if we've actually got any knowledge. So this is really important. The hotel industry communicate quality, if you like, using this 5-star approach. How can we communicate the answers to these questions in a way that is really understandable by people? Because we're communicating with people, not just other professionals, about the quality of data. And so this is something I think our industry needs to look at. So there's the back end around the provenance and the quality of the data, but there's this communication aspect around. If I told you it was raining outside, would you believe me? Not until you'd actually been out there. So that's one aspect. Thank you, Zafar.
Thanks, Leslie. I think you're true. I think more in the age of artificial intelligence, machines are becoming intelligent and humans are becoming a bit dumb. Anyway, let's take this point from a professional industry perspective. Tony, you articulated around the skill shortages. What's your view?
Well, firstly, on the issue of trust in data, as dry as it is, standards offer a big part of the solution. I'm reluctant to press standards too hard, because if standards are at the forefront, then it stifles innovation. But to have proper interoperability between data sets, you must have basic standards, fundamental standards. The second question about the importance of 3D, I don't think it can be overstated. The real world is in 3D. And I've observed recently, over the last 12 months, multinational engineering consultancies move from providing 2D plans to cloud-based 3D delivery methods for their clients. And their clients are loving it. Their clients are now understanding what's being designed for them in a way that they haven't been able to before. They're able to interrogate those models and what's the pipe size that's delivering the water to this building? What's the material? And all of those questions are just so much more easily answered. So I think if we do have a basis of fundamental standards and we move to these models, and as I mentioned before, the models need to be interoperable, because digital twins is just one type of model. There's a lot of models that need to interrelate. So thank you.
Thanks, Tony. We just went 2 minutes on board, but also I think important is the professional body is able to promote the ethics when these sort of tools and data has been used. And I think apart from government organizations and research, I think professional body provides those mechanisms for following ethics and doing their jobs as professionals, isn't it, Tony, as part of that framework? I'd like to now conclude this session by saying I think we all look forward for geospatial taking an important part and maybe a proactive part in the data for decisions, in increasing the geospatial capability, as we heard from our speakers, but also trying to develop enduring and positive impact on climate change using right data, using geospatial information. Folks, thank you very much for joining us today, and have a great day and a great COP26. Bye for now.